Alright, so this is volume of pyramids and cones, practice day 2. This is basically us doing word problems. When we left off on Friday, we were just doing solving basic volume of pyramids and cones. Now you need to be able to apply it in scenario-based situations. Um, and if you remember from the last practice, day 2, I gave you for the prisms and cylinders, there will be a little bit of a lateral and surface area mixed into this. Alright, number 1. A cone used for water has a radius of 3 inches and a height of 8 inches. If it was to be poured into a rectangular prism-shaped cup with a length of 5 inches and 3 inches, a width of 3 inches, how high would the water rise? Round to the nearest hundredth. This is one of those problems. It's just not showing you the shapes. I did this on the last little worksheet that we had was a little packet where they start out with water in one container and then pour it into another. And you want to know how high the water rises in the other container, the bigger container. This one, the shape of the first container is a cone. The shape of the second container is a rectangular prism. So what you want to do is find the volume of the cone first, so you can figure out how much water is going to be in the cone, and then use that volume and work backwards and find the height of the water once they pour it into the rectangular prism shaped container. All right. We've done this problem before. Like I say, it's just usually they show us the shapes. This time they're just telling us what the shapes are. So I'm starting with a cone. Cone is volume equals 1 over 3, capital B times H. Don't forget the 1/3. Anything with a point has a 1/3 in front, cone or a pyramid. Making that 1/3 divided by 3. Jeremy, what should capital B turn into? R squared. 3.14 times our radius, which is 3, times 3, times the height, 8, divided by 3. If you put that in the calculator to the nearest hundredth, you'll get 75.36. This is inches cubed. That is the volume of the water in the cone. They're going to pour that water from the cone into the they're gonna pour that into the rectangular prism shaped cup. So get my right color pen. Here we go. For the rectangular prism, we're gonna find the height of the water. Volume equals capital B times H. Jeremy, since it's a rectangular prism, what should it be? Length times width times height. And on this one, you gotta understand what was given. They gave me length and width. They want me to find height. I'm looking for H. So I'm gonna use the volume that I have and find height. The volume is gonna be 75.36 equals my length, which is 5, times my height, which is 3. My width, sorry, which is 3, times the height, which I'm looking for. Over here, 5 and 3 can go together. Then from there, divide by 15. The height, they want us to round to the nearest hundredths. That's the second time I showed you that. You should have practiced one on your last thing too. Working backwards, working forward and then having to work backwards to find something else. Number 2, I'm gonna do this one with you too. Caitlin made a teepee for a class project. Her teepee had a diameter of 6 feet and an angle the side of the teepee made with the ground was 65 degrees. It's showing you that right here. What is the volume of the teepee round to the nearest thousandths? So on this one, I need to do volume of a teepee. What shape is the teepee? Cone. So we're doing volume of a cone. Has a point, so 1/3 should be in front. Capital B times H. Mm, capital B power squared 3.14 times what do we give for a radius? 3 times 3. And then we need a height. Do we have a height? Yes, no, maybe. I'm gonna go ahead and say no, so y'all ain't gonna say nothing. The height is missing, but this is different from the other ones. My adjustment down here would be 3. We already got that for the radius, 3 feet. We zoom in for those who are gonna be watching the video. That's 3 feet right there. We need our height. Usually we would do Pythagorean, but y'all probably not gonna notice, so I'll just tell you what somebody said last period. The slanted height is missing too. We don't have a height or a slant height. So based on what they gave me, how would I find this height X? It's only a couple of y'all in here, but anybody remember? I just said we can't use Pythagorean because we don't have a slant height. How you gonna do Pythagorean with one number or one side? You only got one out of the 3 sides. You cannot do Pythagorean. What they did give me was an angle of elevation there, 65 degrees. What else have I taught you that we can do? Jeremy, you don't remember? We ain't moving nothing. Everything always comes back. I'll just tell you because I'm losing patience. Last class kid looked it up talking so we could do angle of elevation. I didn't know what that meant. I said, what was that whole unit called? Y'all should still remember. We can use trigonometry on this because they gave me an angle and they gave me 2 sides labeled. I just need to label the figure and then use trig. Jeremy, you should still remember how to label at least. HOA. Slanted side be H. O would be what? O would be the X. Adjacent. Based on that, hopefully your memory coming back to you. Remember which trig function we should use? 10. 10 of what degrees? What over what? I'm waiting on y'all. What over what? You still saying the wrong thing, Jeremy. I was trying to ignore that. Opposite over adjacent. It's in your reference sheet that y'all have. Yeah. What? X over 3. Once you get that, numbers on the bottom, we can multiply by it. Yeah, I probably forgot how to put it in the calculator. 3 times 65 degrees tan. Yeah, it's gonna be a repeating. 0.433 something something something. Hold that in the calculator. We'll use it. Zoom it back out a little bit. So down here, we're going for our height. We're gonna use 6.433. Whatever you have in your calculator, just hold it in there. And we're gonna not forget to divide by 3. So in your calculator, you should already have this number in it. Times it by 3 times 3 times 3.14, then divide by 3. Round correctly, please. 60.604. This is feet cubed. Number 3, I'm gonna do part A for you because I told y'all always mess up on this part. Y'all can do volume very easily. Greenhouse has the shape of a square pyramid, showing you that below. The base has a side length of 30 yards and the height of the greenhouse is 18 yards. All right. If the outer walls of the greenhouse are made up of glass, this is part A. What is the minimum amount of glass needed to cover the greenhouse? Round to the nearest tenth. I'll read this again. If the outer walls of the greenhouse are made up of glass, what is the minimum amount of glass needed to cover the greenhouse? Round to the nearest tenth. What I want to know from y'all is what are we finding on here? Part A, what are we finding? At least you said something. Surface area will not bad, but surface area would include the bottom, Delgado. So we only want to find the walls around the top here. So what kind of area is it? Lateral area. Yeah, if you wanted to include the base, that would be full surface area. But you was on the right track. We just need lateral area right here, the 4 triangular pieces around the top that make the walls. All right. So we're doing LA. We're doing LA of 4 triangles. They're all congruent because it's a square pyramid. Area equals 1/2 BH. And we're going to times it by 4 at the end. Area equals divided by 2. What's the length of the base? What's B? Say it again. 30. And remember, we're doing area. What's the height of one of the triangular faces? You always take these right out. That 18 is the height of the pyramid. We have to do Pythagorean. We need the slanted height on the face. We need that right there. To do that, we've done it enough by now. Y'all should know what adjustment needs to be made. What's half the distance across the bottom? 15 yards. All right. Zooming in on my triangle. I call this A. This is going to be B. My slanted height that I need is going to be C. We can do it right over here in this open space. 15 squared plus 18 squared equals C squared. 225 plus 324, I think that is. Yeah, that sounds right. Equals C squared. Add those together, you're going to get 549 equals c squared, square root, square root. When we try to take square root of 549, it's going to be an ugly decimal, so we're going to leave it as is. 549, leave it like that. That's going to be our slant height. So on our triangle down here, the slanted height which we needed is going to be 549. All right, then we do the math. 30 times that divided by 2. The area of one of my triangles is going to be this decimal. 351.462 something 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 in your calculator. Oh, 4612. I missed the number. 4612. Don't matter. Just hold that in the calculator anyway. We're going to multiply that times 4 because it's 4 triangles that are the same. And then we'll get our lateral area. We round into the nearest tenth. This is area, so it's going to be yards cubed. I mean, yards squared. I said that wrong. Oh, they asked me last period too. Is there another Pythagorean? Not Pythagorean, another trig one on here. Yes, there is. One similar to number 2 is going to be number 6 on the back. I'm not doing that one with you, but you can do that one. It's pretty straightforward. All you got to do is find the volume of the cone, but you got to do trig like we did because you need the height, which is missing. Got one more problem I'm going to do with you. It's going to be on home learning. Number 3. Zoom out just a little bit. This one right here says Ty and his friends went to the park and found fidget spinners all around. They decided to collect them in a triangular box similar to the one below. The fidget spinners only fill up 3/4 the height of the box. What is the volume of the box filled with fidget spinners? Round to the nearest tenths. All right. So part 1 wants you to, or part A wants you to find the volume of the box filled with fidget spinners. But if you paid attention to what I read at the beginning of the problem, there's an adjustment that needs to be made. They said the fidget spinners are only going to fill up the height of the box 3/4 of the way. So we need to make that adjustment to our height before we try to find the volume. The height adjustment is going to happen at the beginning. The height of the pyramid box right now is 19. I'm going to make that adjustment. I'm going to take that original height, 19, and I'm going to times it by 3/4. 19 times 3 divided by 4. What y'all get? Can't hear you. Thank you, Nova. 14.25. Alright, so my adjusted height is going to be that. That's what I'm going to use when I calculate the volume with the fidget spinners in it. So, we use that, we're going to do volume. Over here, it's a pyramid, so we're using 1/3 capital B times H. Volume equals, we're going to divide by 3. Based on what kind of pyramid this is, what capital B going to turn into? Yep. Capital B should be 1/2 BH because it's a triangular pyramid times H. Zoom out a little bit more. And triangular pyramid, triangular base here. Alright. Now we just put numbers in, making sure we got everything. We're gonna see. We might not. Divide by 2. Should save a little bit more space. What's my B for my triangular base? Anybody? 14. I agree. What's my height for my triangular base? Huh? That's the height for the pyramid. Thank you. I'm glad you recognize. I'm glad you just didn't tell me 21.2 or 22.1. Take the lazy way out. This is a Pythagorean. My base and my height are right here and here because this is a right angle right here. Base and height have to be perpendicular to each other. We have to find the height. I can label though. 14, we can call that A. What I'm missing is B. My slanted side, 22.1 is C. 14 squared plus B squared equals 22.1 squared. 196. B squared. This is, I forgot. Let me look. 488.41. Subtract 196. Subtract 196. And then bring down B squared. 292.41 square root, square root. You should always try those. Sometimes the decimals come out clean. On this one, you get a clean decimal. 17.1. That's what I'm going to use for the height of my triangular base. 17.1. It will be right here. All right, zoom out a little bit. So in my formula, 17.1 goes here. I didn't save myself a lot of space, but goes right there. Times the height of the, the adjusted height we're going to use, 14.25. Calculate that, and you'll get 568.6 inches cubed. Part B, not hard at all because you really did most of the leg work for part B already. Part B says how much space is left to fill with fidget spinners round to the nearest hundredths. So what we calculated was the amount of space filled with fidget spinners. Remember, they only came up 3/4 of the height. So to figure out the amount of space left, you got two options. Honestly, the first option just makes more sense, but it's actually the longer option. Would be to find the volume of the full triangular pyramid with the height of 19, and then subtract it from the number that you already got right here. And that's what I usually do. The other option you could take is, since we adjusted the height to 3/4, uh, you could really find out the difference between the height of the regular height of 19 and that 3/4 height, 14.25. You can subtract and then use that height. But I don't think most of y'all gonna get it that way, so that's why I always do it the long way, which isn't bad. I mean, it's not even long. It's just finding the volume of the full pyramid, then subtracting all the numbers you already got. We did all the major calculations. We just got to put it in again. Sum of the volume equals 1/3 capital B times H. Volume equals, we're going to divide by 3. I'm just doing the adjustments to the formula. VH, pretty much same stuff we did up top. Only thing that's going to be different, instead of using 14.25, I'm going to use 19. Everything else is going to be the same. 3 parentheses, divide by 2, and do 14 times 17.1. That height we found, times, like I said, instead of using 14.5, we're going to use the full height, 19. When you get that calculation, you should get 758.1. This is inches cubed. That's the volume of the full pyramid. Then after that, we just want to subtract that full volume we just calculated, 758.1 inches cubed, minus this volume that we calculated up here. Which was 568.8 inches cubed. This will tell us the empty space, or how much space is left. $189.5 inches cubed. All right. Last things last. I'm done showing you problems. I do want to talk about number 4 though. If you make it here, kids do mess up on this one. It's talking about 3 different silos being filled with grain. And they show you the shape of the silos. They give you diameter, they give you height of the cylinder portion, and they give you the height of the cone portion. They gave you everything you need. On this one, there's no need to do Pythagorean at all. All you gotta do is find the volume of the first silo. Find the volume of a full silo, and then after that, they tell you what all 3 silos have in it. Like I said, the first one is 1/3 of the way full. The second one is halfway full. The last one is all the way full. What you want to do is basically find the last one first, because you want to know the full volume of a silo. That's the cylinder portion and the cone portion added together. And then after that, if you want to find the third of the way, you could divide by 3. If you want to find halfway, you could divide by 2. It's pretty simple once you find the volume. But you need to find the volume of the full silo first, though. All right. I want you to do that problem on your own. I don't want to do it for you.